This video is to show you just briefly my summary on how to make a graph in Logger Pro using video analysis. So I'll go fairly quickly because you can play it slower or go back. I'm just going to go through, and we're going to start with insert movie, and you go to the movie file that you want to insert and you plop that in like that. Now we're going to play around with Windows a little bit to make things a little easier to see, right? Like I want to make this pretty much as big as possible. You can see that if I play the video, the ball starts falling. So what I want to try to do really is figure out what frame the action actually starts in. So down here in the bottom corner, right, you've got the bottom left corner, you've got your video controls. You've got play, you've got stop, you've got go back to the beginning, and you have frame forward and frame backwards, which I'm using right now. And I'm going to go back to the point where the ball just stops moving. So about there, and then there, that's the frame it just starts to move. So I'm going to go back, and you can see that that is frame 42. I'm going to note that because that'll make it a lot easier for me to edit later, as that's when I want to actually start my data collection, so that my time, okay, when the motion starts, the time is, I know what the time is, I know where the timestamp is. You can see it's 0.0700 seconds. So we can correct the time to make that time 0 later, and I'll explain that. Down in the bottom right corner is the menu, that's the 3 red dots. The first thing we're going to do is we're going to assign an axis. So I'm going to assign my axis, and I'm going to go right on the bottom edge of the ball, and I'm going to place the origin. Now you can grab the arrow here and you can actually tilt the axis, okay, and you can shift its position, right? I don't know how I managed to do that. There we go. And you can get it where you think you want to get it, okay? And that's not really great because it's on the shadow. I'm going to move it up a little bit more, and I'm going to make it kind of horizontal there. Now I'm going to play the video just to see how it falls. I'm just going to go frame by frame by frame, and you can see that the ball is falling pretty much right down the center there. But if you really wanted to, like, you can kind of make the video a bit more vertical by slightly tilting the axis so that it stays in line with the middle of the ball. Now I'm not very good at this. That's probably good enough. So I'm going to go back up to my first frame, which, if you remember, is 0.700 and 42. The next thing I need to do is I need to establish the scale of the video. So I'm going to do that by using the 1, 2, 3, 4th icon down. It looks like a ruler. Okay, it's not the ruler with the arrow, the red arrow, it's the other ruler. And what this allows us to do is we can drag down on the meter stick in the image, drag a line the same length as the meter stick, and we can assign that line a distance of 1 meter. So now I'm ready to collect data. Okay, Logger Pro knows what the scale is, and you'll notice that the ball doesn't move very much in the first few seconds because it's moving so slowly. So what we're going to do is we're just going to, cheat just a tiny bit when we're adding our data points. And to do that, we need to use the red dot target button. You need to be very careful with this button because if you click anywhere on the screen, it's going to create a data point that you cannot delete from the table. You can only delete it by finding it and selecting it with the white arrow key and then hitting your delete key. So the very first point I'm going to put right at the origin, that's time 0 and position 0. And then I'm going to advance it a couple of frames, maybe 3 frames, so I can clearly see that the ball has moved. And I'm going to click again. I'm going to advance it another couple of frames there, and I'm going to click again, and advance it another frame just manually, and click again. You'll notice every time you click, it advances 1 frame, but you may need to adjust that manually, okay, so that you can clearly see how the position of the moving object is changing. So what you can see is it's recording a series of data points, and I am trying to click on the same part of the ball in the bottom edge all the way down, and you'll see I'm also trying to follow the yellow center line, okay, because really I'm just trying to make sure that I'm measuring straight line vertical motion and I'm not drifting from side to side in the horizontal direction. So I'm going to keep going Keep going, and then I'm going to do one more right here because it's starting to become really unclear. And I'm going to go over here and click on the white arrow because I do not want to accidentally mess up my data. Now what you can do is you can make this graph or this video really small now because you don't really need it anymore. Okay, and you can see I've got a graph in the background, which I'm going to click on right now, and I'm going to make that a little bit more square. And then I've got data here, which I'm going to click on, and I'm going to expand that so I can see everything that's going on here. You can see that we've collected time data, which is based on the timestamp of the video. So you can see that the frame rate is about 0.06 of a second, okay, which I'm not 100% sure. I'm just doing the math really 0.07. I need to double check that. Let's go back and see. Yeah, 0.07. It's pretty small with the frame rate that we have. Okay, so that's pretty big uncertainty in the time there. So I have this nice graph now. Now, you know what? I want to make this axis 0, and I'm going to make this axis here 0. And now we have a graph showing this with big errors in time and not so big errors in position. We can take this graph and we can kind of sort it out a little bit better. Okay, and the way that we can sort it out, oh, I know what the problem is with my time. I know why I messed it up. It's because I was clicking ahead extra frames. So I'm going to go down here where I'm only doing 1 frame. So you can see down here, you can see we got 1.10 and 1.082. So that's about 0.18. So really our uncertainty in time is about 0.02. So I'm going to fix that right now in corrected time. Options, it's not 0.07, it's 0.02. And I'll go back here and I'll fix it in our heading, and then now our graph won't look so stupid. Okay, now I'm going to zoom out really quickly here, and we're going to add a fit line. So I'm going to again drag way on either side of the data here so that we don't get those ugly square brackets. And if you were to do some research, you would recognize that the distance of an accelerating object is proportional to the square of the time. So this is a power relationship or a quadratic relationship because it's a square. So when we go up here to add a best fit line, we're going to use the curve fit button. And if you go down here to, there's quadratic right there. And if you're not sure, you can try the fit and you're like, wow, that looks pretty good. Okay, and that's what it's supposed to look like. So we're going to keep that fit on there, and we're going to go back to the graph that we had originally. Okay, we'll auto scale. I'll change my axes back to 0 and 0, so the origin is the top corner of the graph. Oops, clicked on the wrong button. There we go. And I'm going to move my line down here and click on the graph to get rid of the white shading, and now I have the graph that I need, okay, for plotting position versus time. Now, you'll notice that the software also creates a column called VY. Now, this is the vertical velocity. So I'm going to call this vertical velocity. And we don't really know what the uncertainty is here, so we'll just put meters per second. I'm going to use the superscript button here to put minus, and another superscript to put -1 to show my meters per second in IB format. I like VY. I'll delete these units here. Okay, options, I'm going to go back. I might change the color to something different, maybe black. I'm going to use open circles again. I'm going to make my point protector small, okay, and I've basically done everything I need to do this. So now I've got VY prepared here. I'm going to insert another graph, and so it automatically draws us a nice little graph here. Okay, so I can have more than one graph on my screen at a time. It's no problem. I can save it like this. Okay, look at how beautiful that is. It's a nice straight line, but we're going to actually fix it, and we're going to put vertical velocity on the y-axis, and we're going to put corrected time on the x-axis, and then no data points, so let's auto scale. Ah, there we go. We do have a graph. Okay, this is not the best graph in the world. All right, now these are derivative calculations, so I generally do not trust the first 3 points, okay, and the last 3 points when I'm doing this. So what I'm going to do is I am going to, well, we'll do 2 and 2. So I'm going to select data like this and add a straight line, okay, because the acceleration is supposed to be uniform. And in that regard, okay, uniform acceleration is, you know, it's okay. We've got these nasty brackets on here that don't seem to work very well. You know, they're kind of gross, but they're there and there's nothing we can do about it. But now what we have is we have a velocity time graph that gives us an experimental acceleration value of 9.1 meters per second squared. That's your video. I know it's long. It might help you. It might not. We'll save it. We'll upload it. We'll see if you